This lesson focuses on some of the basics of Algebra 1, Algebra 2. This is the review of the orders of operations. The way we remember this a lot of times is PEMDAS or PEMDAS. Parentheses, exponents, radicals, multiplication, division happen together, left to right. Addition, subtraction, left to right. Here's an example for you where we want to evaluate this expression for 13. So you're going to substitute 13 in for x. So you have 8 plus 6 times the quantity of 13 minus 3 squared. So you're substituting in 13 in for x. So orders of operations says we need to do our parentheses first. So we're going to go ahead and subtract 13 minus 3 and we get 10. Next thing we do is we do exponents. So we're going to take n, 10 squared gives us 100. Next thing we do is multiplication and division left to right. We do have multiplication right here. 6 times 100 is 600. And we add 8 to it. 8 plus 600 is 608. Next thing is the subsets of real numbers. You can just go ahead and pause and read those. Those should be a quick review for you. All right, next is an example of the types of real numbers. So here is a set of numbers, and we want you to identify which ones are natural, whole, integers, rational, irrational, and real. So let's start off with the natural numbers. So if we go back to the slide, the natural numbers. These are what we call our counting numbers. So which ones are our counting numbers? Square root of 81, which reduces to 9. All right, next one, whole numbers. Definition of a whole number are your counting numbers, and they also include the number 0. So we already talked about square root of 81 reduces to 9, and then we also have 0 in there. So those are our two pieces. Integers. C. Head back to this slide. Integers are your negatives of the natural numbers and the whole numbers. So if we look at here, we talked about square root of 81, which reduces to 9. We've talked about 0. And then we can add one more in, negative 7, the negatives. All right, part D. The rational numbers. Definition of rational numbers you want to think about is numbers that can be written as a fraction, a quotient. The denominator cannot equal 0. So think of numbers as a terminating decimal or a repeating decimal. So here's an example of a terminating decimal. Here's an example of a repeating decimal. So if we head back to our group, negative 7 can be written as a fraction, negative 7 over 1. Negative 3/4 is already written as a fraction. 0 can be written as 0 over 1. Square root of 81 reduces to 9, which can be written to 9 over 1. And then there are a couple more, which include 0.6 with a line above it represents 0.666 repeating, or a terminating one as 7.3. So all the ones there in the blue. All right, irrational. Irrational numbers are numbers whose decimals do not terminate, they're not repeating. So here are some examples. Here you can look at the square root of 2, negative square root of 3, our popular pi, negative pi over 2. So our irrational number here set is square root of 5, and pi. Neither of them terminate, nor are they repeating. All right, last one. Real numbers. Head back to our set. Real numbers are everything in this entire box. So it's your rational numbers, your integers, your whole numbers, your natural numbers, and your irrational numbers. So that would be that entire set that we listed above. Parts A through E, all of those solutions. So here are all of our pieces.